In 1977, two spacecraft began a journey that would change our understanding of the universe forever. Voyager 1 and Voyager 2, launched by NASA, set out to explore the farthest reaches of our solar system and beyond. More than 40 years later, they're still out there, traveling farther than any human-made object has ever gone. Voyager 1 and 2 were originally designed to explore the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. These spacecraft were equipped with a suite of scientific instruments to study the atmospheres, magnetic fields, rings, and moons of these distant worlds. The primary mission was to gather as much data as possible about these planets, which were largely unexplored at the time. The information collected by the Voyagers would help scientists understand the formation and evolution of our solar system. But their mission has evolved into something much greater, a quest to understand the universe beyond our home. As the spacecraft journeyed further into space, they began to send back data about the interstellar medium, the space between the stars. This data has provided invaluable insights into the nature of our galaxy and the forces that shape it. The Voyagers have become our silent ambassadors, carrying a golden record with sounds and images from Earth, intended to communicate the story of our world to any extraterrestrial civilizations that might encounter them. In the late 1970s, NASA scientists realized that a rare planetary alignment would allow a spacecraft to slingshot from one planet to the next using gravity assists. This alignment, which occurs only once every 176 years, provided a unique opportunity to visit multiple planets with a single mission. The gravity assists would not only save fuel but also increase the speed of the spacecraft, allowing them to reach their targets more quickly. This innovative approach was dubbed the Grand Tour mission, and it promised to revolutionize our understanding of the outer solar system. This Grand Tour mission would allow us to visit all four of the gas giants, something never done before. The Voyagers provided the first close-up images of these planets and their moons, revealing a wealth of new information. For example, Voyager 1 discovered active volcanoes on Jupiter's moon Io, while Voyager 2 found evidence of a subsurface ocean on Neptune's moon Triton. These discoveries have had a profound impact on our understanding of the potential for life elsewhere in the solar system. The data collected by the Voyagers continues to be analyzed by scientists today, providing new insights and raising new questions about the nature of our universe. Voyager 1 made its closest approach to Jupiter in March 1979. This historic event marked a significant milestone in our exploration of the outer planets. As the spacecraft neared the gas giant, scientists and engineers back on Earth eagerly awaited the data and images that would soon be transmitted across the vast expanse of space. The anticipation was palpable, as this mission promised to unveil secrets of Jupiter that had remained hidden for millennia. Its cameras captured stunning images of the gas giant's atmosphere, revealing a world of swirling clouds and dynamic weather systems. The intricate patterns and vibrant colors of Jupiter's atmosphere were unlike anything we had seen before. These images provided a new perspective on the complexity and beauty of our solar system's largest planet. Scientists were particularly fascinated by the various cloud formations and the rapid changes occurring within them, offering insights into the planet's meteorological phenomena, revealing details of the Great Red Spot, a storm 3 times the size of Earth that had been raging for centuries. This colossal storm, with its deep red hues and swirling vortex, became an iconic symbol of Jupiter. The Voyager missions allowed scientists to study the Great Red Spot in unprecedented detail, leading to new theories about its formation and longevity. The data collected helped researchers understand the dynamics of such massive storms and their impact on the planet's atmosphere. But perhaps the biggest surprise came from one of Jupiter's moons, Io. This small rocky moon, previously thought to be relatively inactive, turned out to be one of the most geologically active bodies in the solar system. The discovery of Io's volcanic activity was a game changer, challenging our understanding of geological processes beyond Earth. Voyager 1 discovered active volcanoes on Io, the first time we'd seen volcanic activity on another world. These volcanoes were not just small eruptions, they were massive, with plumes of sulfur and other materials being ejected hundreds of kilometers into space. This revelation opened up new avenues of research as scientists began to explore the implications of such intense geological activity on a moon so far from the Sun. It also sent back images of Europa, a moon covered in ice, which quickly became a focal point of interest for astrobiologists and planetary scientists. The smooth, icy surface of Europa suggested a young and active moon with the potential for a subsurface ocean, sparking ideas that an ocean might exist beneath its frozen surface. This tantalizing possibility raised questions about the potential for life in such an environment. If an ocean existed beneath Europa's icy crust, it could provide the necessary conditions for microbial life protected from the harsh radiation of space. The Voyager missions thus set the stage for future explorations, as scientists began to plan missions specifically aimed at probing Europa's hidden depths. The legacy of Voyager 1 and 2 at Jupiter continues to inspire and drive our quest to understand the mysteries of the outer solar system. Next, Voyager 1 visited Saturn in 1980, providing the clearest images we'd ever seen of its iconic rings. Voyager 1 also made a close flyby of Titan, Saturn's largest moon, which we now know has lakes of liquid methane and an atmosphere thicker than Earth's. These encounters revealed Saturn's moons as worlds unto themselves, sparking our curiosity about their potential for life. In 1986, Voyager 2 became the first and so far only spacecraft to visit Uranus. It discovered 10 new moons, 2 new rings, and a magnetic field that tilts at a crazy angle. 3 years later, in 1989, Voyager 2 reached Neptune. It captured stunning images of its vivid blue atmosphere, along with the discovery of the Great Dark Spot, a massive storm similar to Jupiter's Great Red Spot. Voyager 2 also found geysers on Neptune's largest moon, Triton, blasting nitrogen gas into space. Both Voyager spacecraft carry a time capsule, a golden record that contains sounds and images of life on Earth. This record is a message in a bottle cast into the cosmic ocean, hoping to be discovered by distant civilizations. Designed by a team led by the renowned astrophysicist Carl Sagan, the golden record was meticulously crafted to communicate the essence of humanity and our planet. The team, composed of scientists, artists, and engineers, worked tirelessly to ensure that this message would be both informative and inspiring to any extraterrestrial life that might find it. The record includes greetings in 55 languages, showcasing the linguistic diversity of our world. It features music from different cultures, ranging from classical compositions by Bach and Beethoven to traditional songs from various indigenous communities. This musical selection was intended to convey the rich tapestry of human creativity and emotion. In addition to music, the golden record captures the sounds of Earth, like the melodious bird song, the gentle rustling of the wind through trees, and the soothing sounds of nature. These recordings were meant to provide a sensory experience of our planet's natural beauty. Among these sounds is the cry of a baby, symbolizing the innocence and potential of new life. This simple yet profound sound was included to represent the continuity of human existence and the hope for future generations. The golden record also contains a map showing our location in the galaxy, using pulsar positions to guide any potential finders. This map is a cosmic address, a way for other civilizations to locate our solar system amidst the vast expanse of space. The hope is that one day, perhaps millions of years from now, another civilization may find this record. It serves as a testament to our existence, our curiosity, and our desire to connect with the unknown. The golden record is more than just a collection of sounds and images. It is a beacon of human spirit reaching out across the stars. In 2012, Voyager 1 made history again, becoming the first human-made object to enter interstellar space. It crossed the boundary of the heliosphere, the bubble of particles and magnetic fields surrounding our solar system. Voyager 2 followed in 2018. Both Voyagers continue to send data back to Earth from billions of miles away, revealing what it's like in the space between the stars. Voyager 1 and 2 will continue their journey through the cosmos, carrying with them a message from Earth, perhaps for eternity. Though we may never see them again, their legacy will endure as symbols of humanity's desire to explore the unknown.
Subscribe and join the journey. Beyond the skies we see each night, there's a vast cosmic landscape filled with billions of stars. Each twinkling light represents a distant sun, many with their own planets and possibly even life forms. The night sky is a window into the universe, a glimpse into the infinite. Our home in this grand universe is the Milky Way galaxy. This majestic collection of stars, gas and dust is just one of billions of galaxies that populate the cosmos. The Milky Way is our cosmic neighborhood, a place where our solar system resides. Join us on this journey as we explore the magnificent structure, history and mysteries of our galactic home. From the swirling arms of stars to the dense core, the Milky Way holds secrets that scientists are only beginning to uncover. The Milky Way is a barred spiral galaxy. This means it has a central bar-shaped structure composed of stars, around which spiral arms wind outwards. These arms are regions of active star formation where new stars are born from clouds of gas and dust. It's composed of more than 100 billion stars, planets and countless other celestial objects. Each star could potentially host its own system of planets, moons and asteroids, making the Milky Way a diverse and dynamic place, and countless other celestial objects. From massive stars that burn brightly for millions of years to tiny, dim brown dwarfs, the variety of objects in our galaxy is staggering. There are also nebulae, which are vast clouds of gas and dust, and black holes, which are regions of space where gravity is so strong that not even light can escape. Stretching over 100,000 light-years in diameter, the Milky Way is a colossal structure. Its vastness is almost beyond comprehension, a testament to the scale of the universe we inhabit. It's so large that even traveling at the speed of light, it would take you thousands of years to cross from one end to the other. Imagine the journey, traversing through star systems, passing by planets, and witnessing the wonders of our galaxy. The Milky Way is not just our home, it's a gateway to understanding the universe itself. Look closely at its structure. The Milky Way galaxy, our cosmic home, is a magnificent spiral galaxy, a vast collection of stars, gas and dust bound together by gravity. The Milky Way has several spiral arms, each one a sprawling, luminous pathway of stars and stellar nurseries. These arms extend out from the center in a graceful, swirling pattern, creating a mesmerizing dance of light and matter. These arms are where many of the galaxy's stars are born. Within these regions, clouds of gas and dust collapse under their own gravity, igniting new stars in a brilliant display of cosmic creation. One of the arms is called the Orion arm, a minor spiral arm that holds a special place in our understanding of the galaxy. This is where our solar system is located, nestled within this arm, amidst countless other stars and planetary systems. It's about 26,000 light-years from the galactic center, a distance so vast it's almost beyond human comprehension. Our sun and everything around it, Earth, the planets, the moons, are all part of this arm. This arm is our cosmic neighborhood, the region of space we call home. But the Milky Way is constantly in motion, and so are we. The entire galaxy rotates, with stars and systems orbiting the galactic center. This motion is a reminder of the dynamic and ever-changing nature of our universe. As we journey through space, we are part of this grand cosmic ballet, moving in harmony with the stars and the spiral arms of our galaxy. The spiral arms are not just beautiful structures, they are the lifeblood of the galaxy, where new stars are born and where the cycle of stellar evolution continues. Understanding the spiral arms helps us understand our place in the universe and the incredible processes that shape the cosmos. So next time you look up at the night sky, remember that we are part of this magnificent spiral galaxy, a tiny but significant part of the Milky Way's grand design. At the heart of our galaxy lies something even more extraordinary, a supermassive black hole. It is called Sagittarius A*. This black hole is about 4 million times more massive than our Sun. The region around this black hole is chaotic, filled with dust, gas and some of the oldest stars in the galaxy. But don't worry, it's too far away to affect us directly. Surrounding the Milky Way is a spherical region called the halo, which contains ancient stars and mysterious dark matter. Dark matter makes up most of the mass in the galaxy, but we still know very little about it. What we do know is that it helps hold the galaxy together, like an invisible glue. The Milky Way is a galaxy in constant change. It is a vast collection of stars, planets, and other celestial objects, all bound together by gravity. This dynamic system is always evolving, with new stars being born and old stars meeting their end. Stars are born in massive clouds of gas, called nebulae, which are scattered throughout the spiral arms. These nebulae are the nurseries of the universe, where the raw materials for star formation are abundant. Within these clouds, regions of higher density begin to collapse under their own gravity. Over time, gravity pulls the gas together, igniting nuclear fusion, and a new star is born. This process can take millions of years, as the gas and dust coalesce to form a protostar. Once nuclear fusion begins, the star enters the main sequence phase of its life, shining brightly for billions of years. But not all stars live forever. The fate of a star depends largely on its mass. Smaller stars, like red dwarfs, can burn for trillions of years, while larger stars have much shorter lifespans. Stars like our Sun will eventually swell, become red giants, and end their lives as white dwarfs. As they exhaust their nuclear fuel, they expand and shed their outer layers, creating beautiful planetary nebulae. The core that remains cools and contracts into a white dwarf, which will slowly fade over billions of years. Larger stars may explode as supernovae, leaving behind neutron stars or even black holes. These cataclysmic events are some of the most powerful in the universe, releasing enormous amounts of energy and scattering heavy elements into space. The remnants of these explosions can form incredibly dense neutron stars, or, if the original star was massive enough, collapse into black holes, regions of space where gravity is so strong that not even light can escape. Believe it or not, our entire solar system is moving through the Milky Way at incredible speeds. Right now, we are orbiting the galactic center at around 514,000 miles per hour. But even at that speed, it takes about 230 million years to complete a single orbit. Our galaxy is also home to countless other planets. Some of these exoplanets may even be Earth-like, orbiting their own stars in the habitable zone, where liquid water and possibly life could exist. Over the last few decades, astronomers have discovered thousands of these worlds, opening our eyes to the possibility that we are not alone in the Milky Way. The Milky Way, like everything else in the universe, has a future. In about 4.5 billion years, it will collide with our neighboring galaxy, Andromeda. Although this sounds dramatic, it's unlikely to cause direct collisions between stars. Instead, the two galaxies will merge over millions of years, forming a new larger galaxy, sometimes called Milky Way. Our journey through the Milky Way reveals just how incredible and dynamic our galaxy truly is. From the formation of stars to the eventual collision with Andromeda, the Milky Way tells the story of our cosmic home. As we look up at the stars tonight, remember that we are part of something much larger.
Subscribe and join the journey.
Welcome to our deep dive into one of the universe's most fascinating phenomena, magnetars. Imagine a star, not burning with nuclear fusion, but with magnetic fury. A star so dense that a teaspoon of its material would weigh billions of tons on Earth. These are magnetars, the universe's most magnetic marvels. Join us as we explore their bizarre properties and the profound mysteries they hold. In the vast cosmic graveyard of dead stars lie objects of unimaginable power, magnetars. They are neutron stars, the ultra-dense cores left behind after a supernova, but with a magnetic twist. Imagine a sphere only 20 kilometers across, roughly the size of a city, yet containing more mass than our entire Sun. This incredible density arises from the collapse of a massive star, crushing protons and electrons together to form a sea of neutrons. But a magnetar takes this density and adds an extra layer of extreme physics. Neutron stars possess magnetic fields trillions of times stronger than Earth's. Magnetars, however, crank this up to a quadrillion times stronger. This immense magnetic field fundamentally alters the behavior of these stellar remnants. The magnetic field of a magnetar is so intense that it can distort the very structure of atoms near its surface. They are the ultimate cosmic powerhouses, tiny in size but colossal in their magnetic might. The birth of a magnetar is a dramatic event, a cosmic spectacle of destruction and creation. It begins with a massive star, many times larger and more luminous than our Sun, reaching the end of its life. Having exhausted its nuclear fuel, the star's core collapses under its own gravity. This collapse triggers a catastrophic supernova explosion, blasting the star's outer layers into space. What remains is a dense core of neutrons, a neutron star. For a small fraction of these neutron stars, a unique process occurs. One leading theory suggests that the initial spin of the neutron star plays a crucial role. If the nascent neutron star rotates rapidly, its internal currents can amplify the magnetic field to extraordinary levels. Thus, from the ashes of a supernova, a magnetar is born, a spinning, highly magnetized remnant. The magnetic field of a magnetar is truly mind-boggling. To put its strength into perspective, consider this. Earth's magnetic field is measured in Gauss. A refrigerator magnet has a field strength of about 50 Gauss. A typical neutron star boasts a magnetic field of 1 trillion Gauss. Now imagine a magnetic field 1,000 times stronger than that. That's the realm of the magnetar, with a magnetic field reaching 1 quadrillion Gauss. This immense power has observable consequences. The intense magnetic field of a magnetar can distort the shape of atoms, squeezing them into elongated shapes. It is a force so powerful that it can unleash bursts of energy that outshine entire galaxies. Magnetars are dynamic and energetic, periodically unleashing their immense power in violent outbursts. These outbursts can take various forms, from giant flares of X-rays and gamma rays to more subtle emissions. One dramatic example occurred in 2004, when a magnetar in the constellation Sagittarius emitted a giant flare. This flare, lasting only a fraction of a second, released more energy than our Sun emits in 100,000 years. The energy released was so immense that it briefly ionized Earth's upper atmosphere. These outbursts are thought to be caused by the intense magnetic field of the magnetar, which stresses the star's crust. These sudden movements release vast amounts of energy in the form of high-energy radiation. Magnetars are cosmic powerhouses, capable of unleashing energy on scales that dwarf even the most powerful events in our own solar system. Imagine a star, not of fire, but of magnetism. Imagine its crust, not of rock, but of neutrons packed so tightly that a teaspoonful would weigh billions of tons on Earth. Now imagine this crust cracking under the immense pressure of 1 quadrillion Gauss magnetic field. This is the reality of a magnetic starquake on a magnetar. Unlike earthquakes on Earth, which are driven by tectonic plate movement, magnetar starquakes are caused by the intense magnetic stresses within the star's crust. The magnetic field lines, twisted and contorted, exert enormous pressure on the neutron-rich surface. Eventually, this pressure becomes too great, and the crust fractures. These fractures release tremendous amounts of energy. The energy released during a starquake manifests as a burst of high-energy radiation, primarily X-rays and gamma rays. These starquakes provide valuable insights into the internal structure and dynamics of magnetars. Peering into the high-energy universe, astronomers rely on specialized telescopes to observe the powerful emissions of magnetars. These aren't your everyday optical telescopes. They are designed to detect X-rays and gamma rays. One of the most important tools for studying magnetars is the Chandra X-ray Observatory, a space-based telescope that orbits Earth. Chandra's sensitive instruments can detect the faint X-ray emissions from magnetars, allowing scientists to pinpoint their locations and study their behavior. Another crucial instrument is the Fermi Gamma Ray Space Telescope, which specializes in detecting gamma rays. These telescopes, along with other observatories, work in concert to provide a comprehensive picture of magnetar activity. Observing magnetars is a challenging but rewarding endeavor, pushing the limits of our technology. The universe is a symphony of vibrations, and among the most subtle yet profound are gravitational waves, ripples in space-time itself. These waves, predicted by Einstein's theory of general relativity, are generated by the acceleration of massive objects, such as neutron stars and black holes. Magnetars, with their immense masses and powerful magnetic fields, play a role in this cosmic dance. When two neutron stars or a neutron star and a black hole collide, they generate gravitational waves that propagate outwards at the speed of light. In 2017, scientists made the first direct detection of gravitational waves from the collision of two neutron stars. While the 2017 event did not involve magnetars directly, it demonstrated the potential for future detections of gravitational waves from magnetar-related events. The study of gravitational waves promises to revolutionize our understanding of the universe. Among the most powerful explosions in the universe are gamma-ray bursts, brief but intense flashes of gamma rays that can outshine entire galaxies for a few seconds. Some of these bursts are believed to be associated with magnetars. Magnetars, with their immense magnetic fields and violent outbursts, are prime candidates for producing these extreme events. The sudden release of energy during a starquake or a giant flare can generate a focused beam of gamma rays that travels across vast cosmic distances. These gamma ray bursts, while short-lived, can have a profound impact on their surroundings. Studying these bursts allows us to learn about the extreme physics that governs magnetars and other high-energy phenomena in the universe. The connection between magnetars and gamma-ray bursts is still an area of active research. The future of magnetar research hinges on advancements in technology and new space missions. As our ability to detect and analyze high-energy radiation improves, so too will our understanding of magnetars. One promising mission is the Athena X-ray Observatory, a future European Space Agency mission scheduled for launch in the early 2030s. Athena will be equipped with state-of-the-art instruments designed to study high-energy phenomena, including magnetars. With its enhanced sensitivity and resolution, Athena will observe magnetar outbursts in unprecedented detail. This data will help us refine our models of magnetar behavior and test our theories about their formation and evolution. The future of magnetar research is bright, promising exciting discoveries and a deeper understanding of the extreme physics that governs the universe. Despite decades of research, magnetars remain shrouded in mystery. While we have learned much about their properties and behavior, many fundamental questions remain unanswered. How exactly do magnetars acquire their incredibly strong magnetic fields? What triggers their violent outbursts? How do these outbursts affect their surroundings? Magnetars challenge our understanding of physics, pushing the boundaries of what we thought possible in the universe. They represent the extreme end of stellar evolution, a realm where the laws of nature are tested to their limits. The study of magnetars is a journey into the unknown, a quest to unravel the secrets of some of the most powerful and enigmatic objects in the cosmos. As we continue to observe and explore, we are constantly reminded of how much we have yet to learn. Thank you for joining us on this journey through the cosmos, exploring the enigmatic world of magnetars. From their incredible magnetic fields to their violent outbursts, these magnetic titans have revealed a glimpse into the extreme physics that governs the universe. But the quest for knowledge doesn't end here. The universe is vast and full of mysteries waiting to be uncovered. Stay curious and keep exploring the wonders of the universe.
Subscribe and join the journey.
The universe is vast, beautiful, and mysterious. But lurking in the darkness are facts that can chill you to the core. From black holes that devour everything in their path to the very fate of the universe itself. Welcome to 10 Scariest Facts About the Universe. Like, subscribe, and share for more content. Black holes are the most terrifying objects in the universe. Formed from the remnants of dying stars, Their gravitational pull is so strong that not even light can escape. Once something crosses their event horizon, it's gone, forever. And the scariest part? There could be millions of them lurking silently in the universe, including a supermassive one right at the center of our own galaxy. Imagine drifting through space and reaching nothing. In some parts of the universe, this is reality. These vast regions of nothingness, known as cosmic voids, stretch for millions of light years. They're almost completely empty, with few galaxies, stars, or any matter. In these lonely voids, the isolation would be absolute. Like, subscribe and share for more content. Rogue planets are terrifying in their isolation. These are planets that have been ejected from their solar systems and now wander alone through the galaxy. With no sun to warm them, they are frozen, dark worlds, drifting endlessly in the cold void. Some estimates suggest there could be billions of rogue planets, unseen and untethered. Fact number 4. The Great Attractor, the mysterious force. Something massive is pulling our galaxy and millions of others toward it at immense speeds. It's called the Great Attractor, a gravitational anomaly in the universe that we still don't fully understand. What is it? A massive supercluster of galaxies, a gigantic black hole, or something even stranger? The truth remains hidden. Fact number 5. The universe is expanding and it's getting faster. The universe has been expanding ever since the Big Bang, but here's the unsettling part. It's speeding up. Dark energy, a mysterious force, is driving this acceleration. Eventually it could lead to a scenario known as the Big Freeze, where the universe expands so much that galaxies, stars and planets become isolated and everything freezes in the darkness. Fact number 6. Gamma-ray bursts, the universe's death rays. Gamma-ray bursts are the most powerful explosions in the universe, releasing more energy in a few seconds than our sun will in its entire lifetime. If one were to occur too close to Earth, it could strip away our atmosphere, wiping out life instantly. Thankfully they're rare, but they're out there, and we would have no warning if one were headed our way. Fact number 7. Time will end, the ultimate fate of the universe. Time may seem infinite, but the universe has an expiration date. One possible end scenario is the heat death, where stars burn out, black holes evaporate, and all energy is evenly distributed. In this bleak future, nothing can happen. No stars, no life, not even atoms. The universe will become a cold, dark, and lifeless void. Fact number 8. The multiverse, endless universes, endless horrors. The concept of a multiverse suggests our universe might be one of many, but this raises a terrifying possibility. If there are infinite universes, there could be universes where the laws of physics are nightmarishly different. Imagine a universe where black holes are everywhere, or one where life is impossible. The possibilities are endless and terrifying. Fact number 9. Dark matter, the invisible killer. 85% of the matter in the universe is dark matter, an invisible, undetectable substance that doesn't emit light, but has a powerful gravitational influence. We don't know what it is, where it came from, or what it's capable of. All we know is that it's out there, shaping galaxies, bending light, and affecting the universe in ways we can barely comprehend. Fact number 10. Supernovae, the exploding stars. When massive stars die, they explode in violent supernovae. These blasts are so powerful that they can outshine entire galaxies and send shockwaves across the cosmos. If a nearby star in our galaxy went supernova, it could obliterate life on Earth. Fortunately, the nearest candidates are far enough away, for now. The universe is awe-inspiring, but it's also full of terrifying mysteries that we're only beginning to understand. As we look up at the stars, it's easy to forget how fragile we truly are in the grand scale of things. Stay curious and stay aware. Be strong and smart, because out there anything is possible. Like, subscribe and share for more content.